Welcome. In this video, I'm going to go over a classic related rates problem, that is a ladder sliding down a wall. So suppose a 10-foot ladder is leaning against a wall. The ladder is sliding down the wall. When the base of the ladder is exactly 8 feet away from the wall, the ladder is sliding outward at a rate of 4 feet per second. How fast is the ladder moving straight down at that moment? As always, let's begin with a picture. So as you can see here in brown is the ladder, and it is 10 feet long. And then my wall is up here along the y-axis, and the ground is along the x-axis. So this will form a right triangle, and we're told that when the base of the ladder is exactly 8 feet away, so this distance here is 8, when that's the case, the ladder is sliding outward at a rate of 4 feet per second. So it's sliding in this direction at a rate of 4 feet per second. So x here is measured in feet, since I know this is 8 feet, this distance, and this is 4 feet per second. So this is the change in x over the change in time. That is, the change in x over the change in time is 4 feet per second. And now let's go back through the problem and highlight our goal. How fast is the ladder moving straight down at that moment? So we want to know this rate, the rate going down. So what we're looking for is dy over dt. That is, we're looking for the change in this y direction with respect to time in seconds. So let's begin by relating all our quantities, and the easiest way to do that with a right triangle is to start with the Pythagorean theorem. So x squared plus y squared equals L squared. In this case, I'm using L to represent the length of the ladder. So I can rewrite this as x squared plus y squared equals 10 squared. And then, of course, let's relate this all to our goal. So our goal is find dy over dt when x is equal to 8. Now, in order to find dy dt, we need to find the derivative of this equation here. And we need to find the derivative using implicit differentiation with respect to t. So I want d over dt of x squared plus y squared on the left and d over dt of 100 on the right. So first, d over dt of x squared plus d over dt of y squared is equal to 100. Now we can apply implicit differentiation to just this x squared here. So this is 2x times dx over dt plus 2y times dy over dt equals, I left something off up above here. Let me fix that. I left off d over dt. Now the derivative of a constant is just 0, so that's 0 right there. So looking at this, I see that I'm given a value for x, so I can fill in this blank. I'm given a value for dx dt, so I can fill in this blank. My goal is to find dy over dt, so I know I won't have a value for dy over dt. That still leaves y. So what is y? Let's figure that out. When x equals 8, y can be found again using the Pythagorean theorem. So that is 8 squared plus y squared equals, and of course, what is our ladder? L is equal to 10. So y squared is equal to 36. This tells me that y is just equal to 6 feet. Okay, this Okay, this sketch looks a lot better. 8 feet here and 6 feet here. So the base of this triangle should be wider than this triangle is tall. You don't have to fix your sketch there. It's a lot easier to just quickly fix on an iPad. Now, before we jump in and plug in everything we know, let's quickly simplify this a little further. That is 2y dy over dt is equal to negative 2x dx over dt. That tells me that dy over dt is equal to negative x over y times dx over dt. Okay, so now I can fill in all the quantities that I do know. That is dy over dt is equal to negative x is 8 at this point, over y, which we figured out here is 6, times dx over dt, which is 4 feet per second, that's here. This works out to be negative 16 over 3. But before I stop, let's just chat about the units really quickly. So I'm going to make a little space here so I can fill in some units. Now remember, 8 is this distance here along the base of the ground here. Here's the wall, here's the ladder, and the distance from the wall to the ladder is 8 feet. So these units are in feet. 6 is this vertical distance here, and that's the distance from the ground to the top of the ladder, so that's also in feet. And then here, this 4 is in feet per second. So this is 4 feet per second. These feet and these feet go away, and we're left with just negative 16 over 3 feet per second. An approximation of that is about negative 5.33 feet. So let's just say 5 1/3. Negative 5 1/3 feet per second. Now let's explain our answer in a sentence. The ladder is moving straight down at a rate of 5 1/3, so 5.33 feet per second. And before you think there is a typo here that I left a negative off, remember this is the y-axis. So as you travel upward on this y-axis from this point of view, the values go positive. When you travel downward on the y-axis, they're negative. So I'm taking care of that negative by saying the ladder is moving straight down at a rate of 5.33 feet per second. I hope this video has been helpful.